Good morning, everyone. It's a great pleasure to participate in this Congress, and I wish that everyone can successfully achieve the goals in it. My name is Marco Antonio Sabara. I am currently a researcher and teacher at the Mechanics Department of the Federal Institute of Science and Technology of Minas Gerais, Congonhas campus, Brazil. I develop work in the areas of maintenance and reliability, failure analysis, asset management, and sustainable development technologies, always addressing issues that study the topic of analysis of uncertainties. This presentation has as its theme the article entitled Uncertainties in Lifecycle Inventories, Monte Carlo and Fuzzy Sets Treatments. Having made this brief introduction, let's go to the work overview. The Lifecycle Assessment, LCIA, is an impact research methodology that focuses on the life cycle of a product, by extension, services, and is standardized by the ISO 14000 series. This methodology has been applied in so many areas related to sustainable development in order to evaluate the environmental, economic, and social aspects of the process of production and distribution of products and service goods. Despite this wide range of applications, the technique still presents weakness, especially in the question of the evaluation and expression of the uncertainties present in the various phases of the studies and the inherent to the stochastic or subjective variations of the data resource and source and the generation of models, sometimes reducing the consistency and accuracy of the proposed results. In the present study, we will evaluate a methodology to deal with the best expression of such uncertainties in LCIA studies, focusing on the life cycle inventory phase, LCIA. The hypothesis explored was that the application of the Monte Carlo simulation and fuzzy set theory to the estimation and analysis of the stochastic uncertainties in LCA allows a better expression of the level of uncertainty in terms of the guide to expression of uncertainty in measurements, ISO GAN 2008, in situations where the original life cycle inventory does not specify the initial uncertainties. The iron ore transport was selected as a process unit by means of an off-road truck with a load capacity of 220 tons and a power of 1700 kilowatts, acting the road between the mine and the primary crushing of a mining company in the city of Congonhas, Minas Gerais, Brazil. Monte Carlo simulations and fuzzy set theory applications were performed using spreadsheets in the MS Excel software. The LCA study was conducted in OpenLCA 1.6 software, open source, from data inventories of ELCD database 3.2, also freely accessible. The results obtained were statistically compared using hypothesis tests and variance analysis to identify the effect of the techniques on the results of the life cycle impact assessment, and a sensitive analysis was performed to test the effect of the treatment and function of the distribution of probabilities in the expression of the parameters associated with the items of the original life cycle inventory. Research indicates that inventories with treated data may have their uncertainty expressed to a lesser degree than that expressed in the original inventory, with no change in the final values of the life cycle impact assessment. The treatment of life cycle inventory data through Monte Carlo simulation and fuzz set theory resulted in the possibility of expressing the LCIA results with a degree of uncertainty lower than that used to express the uncertainty under the standards. Finally, data treatment through Monte Carlo simulation with normal probability distribution showed the lowest values of uncertainty expression with significant difference in relation to the original inventory at the significance level of 1%. I thank you all for your attention to this brief presentation, and I am available to answer any questions you may have through the communication channels made available by the event organizers. Thank you so much. See you soon.